Hello. When you're discussing the thermal envelope of a building, it's important to talk about windows. Choosing the right windows is one of the most important decisions for any project. Why? Because the right windows can reduce your total energy consumption and decrease the lighting costs and definitely decrease the heating and cooling costs. And it turns out that the size of the window, the orientation, whether it faces north, south, east, or west, and the type of window, how it's constructed, triple glazing, aluminum frame, etc., all right, can dramatically affect the overall energy performance of your building envelope. So here we have some examples of thermal imagery from the color plates in your textbook. Remember that the color plates are located kind of in the center section of the textbook. All right. And on the left, we have an image from the outside of a building. All right. You can see the bright spaces are where the heat is escaping from this building through its openings and also through parts of the wall that aren't well insulated. Right. On the right-hand side, we see a thermal image of the inside of a room, right? And you can see it's cold outside, and therefore the windows in this image are very, very dark, right? Because the heat is escaping through there. So windows in general account for about 30% of the heating and cooling load for a building. So it's very important, like I said in the last slide, to choose carefully. And they also have a big effect on thermal comfort of the people in the space, all right, because of their effect on the mean radiant temperature, MRT. But that doesn't mean that you should avoid windows. Here's kind of an interesting illustration from your textbook. I think this must be um, like a vintage magazine ad or something. It says which building will require less heating energy, and it turns out that south-facing windows will admit more heat by radiation or emit heat faster than they lose heat. All right, so we don't have to avoid them um, as long as we choose high performance windows. Windows do not have to be the same R value as the walls that surround them. All right, and in the summer, it's actually more important that they be shaded than anything else. So instead of using the additive method of just adding up all the R values of the different materials like we did with walls, it's important to consider windows as a whole construction piece of them themselves because of the very different properties of the glazing, the glass, and the frame around it. And so each individual window unit that is sold here in the US is going to have a label. It's been tested and will be labeled with its different criteria or different metrics. And so here's an example of the NFRC label, National Fenestration Rating Council. All right, and each of those labels is going to show the U factor, the solar heat gain coefficient, the visible transmittance, and the air leakage for that particular window unit. Let's take a look at this one. It is a vinyl clad wood frame double glazing argon fill low E vertical slider. All right, so it's very, very specific to that exact window type. Let's talk about those four metrics or four criteria. And the first one is U factor. Remember that U is the reciprocal of R. We've been talking about the R value for the walls. Windows are standard. Their information is given with the U factor. The U factor measures how well a product can keep the heat from escaping. All right. The lower the number, the better the product is at keeping the heat in. Your typical range of U factor is going to be between zero point 0.2 and 1.2, and when selecting a window, you want to look for the lower numbers. The solar heat gain coefficient measures how well your window product will resist unwanted heat gain. All right, it's especially important during the summer, and the lower the number that you pick, all right, the less you'll spend on cooling. The range is from 0 to 1, all right. 0 is absolutely no heat is transmitted through this glass, and 1 is all the heat. All right, so this is a percentage, and you want to look for the lowest number. Visible transmittance. It measures how well the window will light your home, how much light will come through this window. The higher the number, the more natural light is let in. The range, again, is from 0 to 1, from no light, completely black or opaque, to 1, just like there's no glass there. All right, so you want to look for high numbers in this case because you want the light to come in. All right. In the late 70s, early 80s, when people were trying to get better energy efficient windows, all right, there were some dark or smoked glass that had low solar heat gain coefficient. All right, and that was good. It was important to keep the heat out, but it also had low visible transmittance. Not much light came through the window, or a lowered amount of light. All right. We have better products now where you can get the low solar heat gain coefficient and also full or high visible transmittance. The final window criteria on the NFRC label is air leakage. It measures how much air will enter through a product, how drafty, all right, how much is going to sneak in. And you're looking for low numbers, so you get a little amount of few drafts, excuse me. And what you want is a range that's less than 0.3. Thanks, everyone. Windows are an important part of your thermal envelope, and you'll have to be very careful in selecting them for your projects.